Hi everyone, thanks for joining us today for Mastering Multibody Design. This is the first in the series of upskilling sessions designed to help you guys get the most out of your investment with PTC products. Now we've got a number of webinars coming up. Some are like today and they're deemed full masterclass sessions which last around about an hour. We've also got a number of mini masterclasses. Now these are only available via our LinkedIn page and they're a little bit shorter but still got some great content. And you can only get those by following us on LinkedIn. So be sure to follow us on LinkedIn to get kept up to date with when they're released. Now, just a little bit of housekeeping before we get stuck into today's session. If you've got any questions throughout the presentation, please feel free to use the chat function in the webinar tool, and we'll endeavour to get back to you as soon as we can. If for any reason we don't get back to all the questions, we'll pop them in an email and send them out to everybody at the end of the webinar. My name is Lloyd Stevens. I'm the Customer Success Manager here at Concurrent Engineering. So if you do have any queries, please feel free to email me direct on that email address at the bottom of the screen there. Doing the main presentation today is Matt Bancroft. Matt's main role is the CAD pre-sales advisor here at Concurrent, but he gets involved in a whole host of different areas of the company, including the customer success team. So without further ado, I'll pass you over to Matt to take us through the main presentation today.
Thanks for the intro, Lloyd, and a big thank you to everyone joining us today. Creating parts in Creo has always been a straightforward and robust process. Using geometry to add or remove material, extrude, revolve surfaces, sheet metal techniques have allowed users to capture their design intent with confidence and accuracy. You build your componentry one piece at a time, knowing that the dimensions and features created will behave together at assembly level and give you the intended results. However, it's sometimes a little of a challenge to entirely capture your ideas with this method. If your designs have shared references at part level, or if you require related geometry to affect your design in a more sophisticated manner, there are inherent limits when only single bodies are included in the graphics area. From Creo 7 onwards, users now have the new functionality of being able to model at part level using multiple bodies concurrently. This is a game changer for Creo. It gives users a hugely more flexible and powerful set of options to use Boolean operations to manipulate geometry in a far more controlled way than previously. Today we're going to have a look at this new functionality in various scenarios, which aim to give you a clear overview of how to apply these techniques to your everyday tasks and speed up your workflow. We'll look at picks and clicks first, and then move on to specific use cases. Using bodies as design tools, flexible modelling, additive manufacturing, and then a couple of extra use cases, for example, using in drawings, etc. So let's start with the basics. So let's start at the beginning and look at the basics. What we have in our model tab from Creo 7 onwards is a separate new section. This is where our multi-body modelling can be done. The first button there, Boolean operations, opens up this new dashboard where we're able to merge, intersect or subtract bodies from each other. We also have the ability to split a body, which we'll look at later on, and also create a new body on the fly if needs be. On this very basic example, let's have a look. We've got 3 sketches here. We have the base, the back, and then this spline here that we're going to use in a moment. So if we start off by simply extruding the first sketch, so if I select the sketch and extrude, and I'm going to do it at 50 millimeters. And OK. So as far as we've gone so far, really similar to previous versions of Creo. So let's now go for sketch 2 and extrude. Now again, I'll just drop that down to say 30 millimeters. What you can see at the moment, by default, it's created as added geometry, of course, but also this new in the body options, the ability to create a new body. So I'm going to then create this as body 2 here. So what we can see now is we have the part as it looked, but 1, we can see we've got 2 bodies here. Body 1 is the base, and body 2 is the back. Thirdly, with the next sketch, I'm going to extrude this as a surface. I'm going to do it up to this surface here. So to a reference, at that point there, I've now got a surface that runs through. Let's just hide out those other 2 bodies here. Okay, so we have body 1, body 2, and then this surface. So we have the 2 bodies and then the surface that we can use to drive design intent as well. So going back up to the multi-body area here, Boolean operations, we can merge. For example, we could merge body 1 and body 2 to create a complete body between them. We could intersect and find the area that is left using these 2 bodies there, for example. As you can see, we've got the bit where it actually shares geometry. We can also remove one from the other. So I could say I'm going to remove this body from this body. And leave me the geometry left. And I've also got the ability to split a body. So if I go to the split body and say in the body I want to split, so I'll say this one here, using what? I'm going to use that surface. So that creates 2 parts here. So I'll go down to the body here and see I've got the top and the bottom half. It's a very simple process. What it allows you to do is basically build up geometry as you require. It gives you a lot more control over previous versions, and it allows you to manipulate and work with the geometry in a whole new way. Also, it gives you this idea here where we've got the body 1, 2 and 3. So these can be specified as particular parts of the geometry, but also what you're able to do is create a part from that specific body as well, or indeed convert to sheet metal. Okay, so it gives you many more opportunities to properly gain your design intent. So what we're going to do over the next little while is we're going to look at different examples of how this technique can be put into your daily workflow. We're going to concentrate primarily on relatively simple examples, so you can take that as a reference and go back to your work and apply those techniques to your daily designs. Now, one of the main advantages of multi-body design is that you can use bodies within your parts to influence each other and to alter the geometry. So let's have a look at some of those examples here. Here's a nice example of where you could use flexible modelling to create geometry that's going to fit together correctly. Really basic little wheel with a tyre. And what I've done is I've created it using the multi-body. So you can see with the bodies here, we've got two parts. We have the wheel itself, and then the tyre that fits correctly around the original wheel. Now, in traditional modelling, this would be relatively easy enough to do, but would take a little bit of thought and a little bit of planning to make sure that the tyre, if you think about it just being a little plastic component snapping correctly onto the wheel itself. So let's have a look at the process of how I put this together. Okay, so we've got the wheel itself here. Look, I've scrolled back the model tree to the point before I created the tyre, so we just replicate that same process. I'm not going to worry too much about how we make the wheel itself. I think most of us could do that. The important thing is looking at this new functionality regarding the multi-body. So I'm going to put the second revolve on here and use this as a reference, the actual wheel itself as a reference. So I'm going to select that from plane and go to revolve. Put my centre line in. Always remember the centre line. And then I'm just going to basically project this on the surface here. Delete out the bit I don't need, and then thicken, chain with flat ends. That one. Hold down control, get the second, thickness of 10, and then it's pointing downwards, so I'm going to do -10 as the thickness of the tyre itself. So I'm happy enough with that. And you can see what's happening is we're getting the shape being filled out. Now what we need to do is make sure that these initial lines here are taken out. Okay, so we're just going to delete out that one, and you can see that we actually get the full there. All right. Now that, as we know, is fairly straightforward, but what the options we have here is this body. And what we're going to do is we're going to create a new body here. Okay, and what this means is within the same working environment, we've actually got two separate entities, two separate models, which prior to Creo 7 you weren't able to do. So if you just OK that, you can see, first and foremost, we've got the body here, so we've got the wheel, and then we've got the tyre, and this body 3 essentially is replicating this first tyre that we made there, so we can replace that and rename it to say tyre 2. Let's just try that again, rename it tyre 2. Okay, and simply with tyre 2 selected there or here, we can mirror in itself and create this nice tyre. Now what this gives us is the ability to essentially make sure that the geometry is absolutely correct. So the existing wheel, which we would require as being a reference so the tyre snapped nicely around it, would be more difficult to do with separate parts. As I said earlier, you'd have to remember the specific geometry of it. But this allows us to basically design essentially in context. Very, very straightforward. And once you get used to that, making sure you remember when you're doing the revolve itself, this revolve here, make sure that you do go into the body options there and create the new body at that point. Okay, so very simple, but a nice example that you could take to your own workflow and think about how it might work with your existing models that you're working with currently. Okay. Now, one of the advantages of working with multi-body modelling is that you can influence certain aspects of the design without influencing all of it, which is really useful. We'll have a look at a couple of examples here. So for this example, we're going to have a look at how multi-body design can give us a lot more control over removing material from existing componentry. You can see on this little moulded part here, relatively simple of course, but what the clever bit is this ability to use this pattern to remove material from just some of the part itself. If you think about how you do that in the traditional sense, it's a relatively complex way of gaining this particular geometry. Okay, so just removing from a specific part of the part. So let's have a look at the workflow for that. And we'll do it right from the start so we can see the entire process. So let's begin by creating the first component. With an extrude on the top plane, a couple of circles, set that one at 50 millimeters, Second one over here, that's 30. And then an offset of 100 mm between the centre points. Then I'm going to use the arc and ensure it's tangent to both circles. And then use the newly developed mirror. So I don't need to specify a centre line as such. I can use the existing geometry and then remove the material I don't need. Okay, it's looking good. I'm going to set that with a height of 40 mm. Nice. So now I'm going to create a second body that's going to manipulate the initial body that we've got here. So I'm going to extrude on this top surface here, and I'm going to use the offset loop and then do -5 so it comes in 5 mm. Close that and OK it. And at this point I want to create a new body. So I've now got body 2. And I want it to go basically to the same reference as the original. So OK that. The next Boolean operation I'm going to do is going to remove body 2 from body 1, but keep body 2. So if I go to Boolean operations, I'm going to subtract body 1 is the one I want to modify, body 2 is the one to take away. Now by default you can see it's taking it away, but actually I want to keep body 2, so I've got this option here to keep bodies. So OK that. So now I have body 1, body 2, body 1, body 2. Okay. The next process is I'm going to remove material just from body 2. So I'm going to extrude on this central plane here, front plane, and I'm going to do a circle here, and then OK that. Symmetrically, make sure it extends beyond the geometry here. And again, I'm going to create a new body with this. And OK that. With this new body, I'm going to pattern all the way to this far end. So I go to my pattern, direction pattern, use the datum plane. Always a good idea with patterns, use the datum plane as a reference. Have the spacing at say 15 and have enough to get to the far end. So I'm going to put in 12. Plenty enough. OK that. So I've now got 3 bodies. Body 1, body 2, and body 3. So again to the Boolean operations, I'm going to remove body 3 from only body 2. So Boolean operations, subtract. The one I want to modify is body 2 here, and remove it using this one here. In this instance, I obviously don't want to keep the bodies, because I'm using it as a removal tool, so I OK that. So you can see what I've got now. It's quite a nuanced design. It's taking material away from the original. Body 2 works beautifully. So if I then select all 3 and put them as a merged entity, I'm going to say, OK, this one, modify this one, and it creates one body. So then further manipulation, for example shells and things like that, would work as required. So I say that surface there, say set it at 2 mm. I've got a nice, quite relatively complex design that's made using the basic functionality of multibody modelling. This would have been very tricky to do in previous versions, I think. And it's just a very simple but very effective example of how using this new functionality gives you a lot of control and gets you far closer more quickly to the desired result. So for this example, we're going to have a look at using multi-body modelling techniques when creating mould stocks. So we can see we've got our little familiar part here in the centre, the little plastic moulded component. At the moment I've got the mould stocks top and bottom using the split line datum. Now what we're going to do is replicate this process. I'll show you it from the start to the finish. And while it's not necessarily a full replication of the full mould cast design, not all of us have that, and for a quick fix and for a way of creating the mould stock basics, is a very efficient and very straightforward workflow for this. Okay, so you can see at the moment we've got the three parts. We've got the moulded part itself, there it is, mould base, which I've made transparent just for ease of use here, and also the mould top, which you can see there. Now what I've done is I've taken a little bit of care in creating the split line using this flat reference plane here to determine where the mould will come out. So let's show all of them again. And what we're going to do is we're going to work through this process. I'll show you how we kind of put this together in the most efficient, straightforward way. Now we're going to be using this exercise as a demonstration specifically regarding mould stock creation, but of course you can use this same functionality for a host of different modelling techniques or requirements. Simply using one body to remove material, very specific material, from another, and either retaining both or just retaining the resulting body, is a very effective and very efficient way of working, and one that certainly wasn't available prior to Creo 7. So we're going to go through the mould stock example on this one, but of course do take it back to work and think how it might apply to your existing workflows and any kind of models that will require this specific kind of control. So what we're going to do is we're going to build up the stock around this part here. So I'm going to go with the split line datum and sketch a rectangle, making sure it fully encases the part itself. We'll put some dimensional values in here. We'll set that at say 240, this one at 480. Okay, and then I'm just going to make sure that this is centralized, so I'll just go one down to here and make sure that's 120 there. Okay, set that one at 110, make sure it's quite correct, and okay that. Now you can see at the moment all we've got is that it's moved down from the datum, so let's move that back up to, say that's 80 mil from the base. And then on the second side here, if you go to your options tab, you can specify that the second side is also variable, and I'm going to set a depth option there at 40 mil. We're also at this point going to create the new body, so it is seen as a specifically a separate part to the original moulded component we had in there. So let's OK that. So what we have now is we have in the design items we have the moulded part and the stock. So we now need to split the body. Okay, we're going to use the split body technique that we looked at earlier on. I'm going to split this specific body here, and we're going to be using the split line datum to split it in half. So that has then created us a further body. So if we go to our body drop down here, you can see that we have 1, 2 separate. Okay. Now the next technique is we're going to remove the original moulded component from these two, so creating the mould stocks. So again up to our Boolean operations, and we're going to subtract from this top part, and we're going to use the moulded part to remove. Now bear in mind we can specify at this point whether we want to keep the modifying body, which we do need to. So I'm going to keep that body and OK that, and then simply repeat the process here by doing a further Boolean operations, subtracting from the bottom part with the moulded part, and again, keeping the body. So we're okay with that. So what you can see now then is if we look at these specific bodies, I can hide out that one. So we've got the components. We hide out the components. We have the base of the mould. And it's a very clear and very straightforward process to make sure that the geometry is absolutely correct. Of course, it can't entirely give us the same kind of functionality that the full mould and cast extension will give you, but as a technique for creating voids or gaps in your geometry, it's brilliant, and something that's not been, as we've said before, not been available in previous versions of Creo before Creo 7. So if you've got Creo 7, and particularly in Creo 8, the workflow is even more smooth and easy to work with, particularly with these dashboard options and the ability to kind of control how they're shown on the screen. I'd absolutely recommend that you do at least contemplate moving up, because it does give you so much more in the general workflow of not only simple modeling techniques like these, certainly more complex modeling. It will give you a little bit more functionality and certainly more flexibility when getting the desired results. What we're going to do with this example is have a look at using the new functionality of the multi-body modeling up here, specifically split body. And then we're also going to use some flexible modeling techniques. Now, flexible modeling is something that a lot of designers I speak with are either not fully aware of or haven't had training on it, or a little bit aware of the fact that it's not in some ways strictly engineering in its process, it could be argued. However, in the right context, I think it's great. So let's have a little look at that in a moment. First thing we're going to do is we're going to have a look at this basic component with the ultimate aim of having this front right section being split off from the rest of the component and moved down just slightly. So to do that, what we're going to do is use the split body function. Now, the split body function allows us to basically cut the part into separate entities, separate bodies within it. So I'm going to select the split body, and it's saying which body do I want to split and what I'm going to split it with. So obviously I'm going to split this body itself and the splitting object. Firstly, I'm going to use this front datum. So you can see that it's now split it into the two halves. If I OK that, you can see now I've got body 1 and body 2 in the design tree here. I'm then going to further split this second body into half as well. So if I go again to split body, say I want this body splitting using this right datum here. Okay, so I've now got 1, 2, 3 bodies. So that's great. Now what's going to be happening now is that I'm going to be moving this front section down a couple of degrees. So I'm going to go to the flexible modeling tab here. I'm going to specify, using this to specify a body. So this body here, I'm going to move. And what we've got is this 3D dragger that we're aware of from our assembly work, essentially. At the moment, the origin here is kind of free. It's in the middle of the part itself. I really want it to the center. So let's turn that off, put my axes on, and I'm going to say instead of the origin there, I'm going to specify this central axis here. Now this means that my degrees of freedom are whited out, and it just allows me then just to tilt this. If I just tilt it slightly down like that, let's not go quite for 9 degrees, I'll just go for 2 for the argument's sake. And now I've got this 2 degree split, which is fine. You can see from the front now, it just dips down a little bit at the front. But obviously with that tilt, I've also got this gap here. So you can see with the gap, going back to geometry, I need to kind of fill in this area here to make sure that it's complete shape. So the next step I need to take is to make sure that this is now viewed as a single entity again. So I need to basically merge these 3 bodies together. So if I just go to my Boolean operations at the top and the left here, and I want to not intersect or subtract, I want to actually merge, union these parts together. So I'm going to say the body to modify is that one, and I want to modify it with that one, and hold down control, that one as well. So that gives me essentially one body. It's now gone to body 3 out of the 3 bodies that were originally there. So if I have a look here and go to body and hover over it, it's one entity. What I'm now going to do is actually use the remove function to basically heal this area here where it's missing the correct topology, essentially. So if I go to the editing and go to remove surface, and I go to that surface there, that's the one I want to take out. Now by default, it may or may not. If it doesn't do that straight away, you can go and maintain the surface topology if required. Generally, it has the intelligence to find it for you though, but what you can see is it's actually completed that geometry there to maintain the design intent that I require. So if I OK that, you can see that it's completed it nicely. So I've got that 2-degree tilt of that front right section. I can then close it, make sure it's all the right colour. And there we go. So what we had there was the split body. So cutting the thing into separate entities, using the flexible modelling, so moving that particular section at the front, then using the remove surface after merging the bodies together, and then completing as required. So really simple, very effective, reliable process really to get the work done. Multibody modelling also lends itself brilliantly to the workflow for additive manufacturing and generative design. Let's have a look at an example here. A lot of us are starting to look into the potential and the workflow regarding generative design and lattices. I use them quite a lot within my designs. And as you can see, this very basic example here, we've got this lattice within this frame here. Traditionally, it's relatively complicated in some areas to make sure that the lattices work as required, and actually kind of creating the gap or the space is another relatively cumbersome job. So this is an area where multi-body modelling does lend itself quite nicely to kind of simplifying the workflow itself. So let's have a look at how I put this example together. So here's the basis of the bracket itself. And what I'm going to do is use a second body to create the space I'm going to fill essentially with the lattice. So let's go onto this particular surface and do an extrude. And again, I'm going to use the offset option here, loop, and then pick this specific area here. I'm going to send it in 10 millimeters here, and OK that. At this point, I'm going to create a new body and say I want it to reference up to this surface here. Okay, keeping the body itself. So I've now got, look at the bodies themselves, I've got body 1, which is still the big one, body 2 is the inside one here. So what I'm going to do is remove this interior body from the first one, but keep the initial body. So again, up to the Boolean operations, I'm going to subtract from the big body with the smaller body and keep the bodies at that point. Okay, so I've now got this part here, so body 1, body 2. Now what this gives me is the ability to actually control the latticed area in a far more kind of logical way, I feel. Traditionally, kind of creating that area, that space to fill the lattice was fine, but it did give you kind of extra jobs to do. So what we're going to do is we're going to use this second body, the interior body here, as the basis for the latticed area. So I'll go to my engineering drop down here and down to the lattice. And what we get in this first lattice region drop down, this tab here, is the first option is to replace the body with the lattice. So if we just select that, it automatically selects body 2, and it gives me a preview of the lattice itself. Obviously, I've got different options regarding beams, 2.5D, even formula driven. We'll stick with the beams for the time being, and also look at the cell direction here. We can change that if needs be, X, Y, Z as required. I then go to my cell type. I'll get different options regarding the shape of the actual cell within the lattice. So we can go triangular, square, hexagonal, octagonal, or stochastic, which is slightly more complex and uses a little different kind of geometry settings and formulas to drive that. We'll stick with the basics for the time being. We'll have a look at hexagonal in this instance. You can obviously set the cell size, so let's drop that down slightly. We'll go for 20 on each. And then in looking into the cell fill tab, we can look at whether we want to keep the ball diameter or alter that. So let's change that down to say 5 mm, and also the cross section size. So I'm going to make the actual lattice beams thinner. Okay, so you can see with the preview there, we're getting the intended lattice type. Here I have the option to do full geometry, simplified or homogenized. I'm going to stick with full geometry in this instance and then just press OK. What you'll see is the formula is driven, and we'll just wait for that to work itself out. And there we are, very quickly it creates the latticed region. It gives us strength, but also increased lightness, reduced mass obviously, and it's a very quick and simple process, and much easier I feel to manage than previous versions of Creo. I can obviously go back into the lattice itself, adjust the geometry within it. So if we just drop, say, the cross-section size down to 1 in this instance, make it a much finer lattice. Just wait for that to redo itself. There we go. So it's a much simpler process, very easy to kind of manage and control. And using the multi-body functionality gives us a very clear definition of the area that we're going to use as the basis for the lattice itself. So we've been through quite a few examples there of using multi-body techniques in our Creo designs. So what's the next step? Obviously what we really need is to make sure that these parts are manufacturable, particularly with this mold stock example here that we've got, that the parts can go out to the drawings and the tool maker. So at the moment we do have the different bodies in here, but what do we do next? So you can see we've got, in this example, we've got the mold base there, and the mold top here, and the mold part itself, which realistically the toolmaker doesn't really need to see. Let's be really honest about it. So what we really need to do now is to create parts that can be put onto the drawings. And this is such a simple process. So within this actual multi-body part, what we've got is the ability to create a part from the body. So I can then set that there, give it a name, make sure we're using the right template, and there's the base itself. Now this, of course, can then be used at drawing level to make sure that the tool designer, the mold maker themselves, is able to then modify this and use it as required, take measurements from it, etc. So really what we're getting is the ability to work with the multi-body modeling technique and bring it into the mainstream design workflow. Really simple, really straightforward to work with. As I said at the start of the webinar, the ability to use multi-body modeling within Creo from Creo 7 onwards is a real game changer. It gives you far more control, far more oversight, far more flexibility when working through your design process. It's a brilliant addition to an already brilliant piece of CAD software. Hopefully some of the demonstrations today have sparked some interest and given you some ideas about how you can take this workflow back to your own designs.
So I'd just like to say thanks to everybody for joining us today. Keep an eye on our website for new masterclasses, and be sure to follow us on LinkedIn to get the first look at our mini masterclass series. Of course, if you've got any questions, please feel free to drop us a mail. Thanks everybody. Goodbye.